was available, single screw, twin screw, multi-screw, ring screw available. And once the pellets have been actually homogenized in the viscosity, to some extent impurities removed, then it comes into the SSP process of polymetrics. So what polymetrics does is that if you get a viscosity of 0.64, which is also used for yarn, it is now lifting it for bottle. Bottle, we increase the viscosity up to 0.84. So if you look at it, it's a 0.20 lift. Now what does this lift do? It strengthens imparts strength in the polymer. So when you actually form a bottle, it can withhold pressure of carbonated gases, and if you throw it from 3 meters top, it will not burst. So we have a process there, we'll keep it for 14 hours in that. In those 14 hours, you have to also remove impurities which are generated because of the recycling process. So what do you get? Impurities. You get acid halide. So you might have noticed sometimes the bottles are filled all the way to the top because the polymer quality is not good, and when you open it, you will get a whiff of some chemical. That is acid halide. Then you get leftover glue, which is actually also there. So that becomes a part of the polymer in the extrusion. Much of it is removed in washing. So we remove, that kind of impurities too. Then we get some things from sugary substances, where it is called a limonene. So you have to remove that limonene. There's cyclohexane, there's benzene. These are the impurities you need to remove, and then finally have a very clear color. So we have to ensure that we don't degrade the color, because clarity is very important in any food application of water or film or sheets, because if you see that it is opaque, then you immediately get a reaction that something is wrong in this water, but actually it's the bottle. So this is our process. Currently in India, we have many plants running, largest being 1100 tons per day for virgin. So the production in India in virgin PET is 2 million tons per annum. Now, we need to circulate this, recycle this into bottles. Earlier, it was only driven by companies, but today government has brought a legislation realizing that unless and until you recycle, the landfills will become untenable in a few years. So they have mandated that 30% have to be used. So from 2025, this is a government driven. And because it is government driven, it is going to expand. So that means you need to recycle 600,000 tons, 600,000 tons or 6 lakh tons a year. The current capacity of our PET approximately is 1,50,000 tons. I'm only talking of bottle, I'm not talking of fibers. And that is 83 tons a day. By 2026, with the capacities coming up, it is expected to increase to 400 or 5 lakh tons per annum to make it 23% of the production. So there is still scope for more. The other challenges we face is that we offer plants which can do up to 10 tons in a single line per hour, which is unique. The others, maximum capacities available are about 4.5 tons. In this, there is also a challenge, because in the bottle grade process, for mineral water, you need a different viscosity, like 0.76 or 78. And for CST or carbonated soft drinks, you need 0.84. Now, if you have to have a large plant of 10 tons per day, it could become difficult to sell. So we are now adapting processes where we can have one single extruder of 10 tons an hour, and feeding 3 different SSPs with 3 different viscosities, which you can produce in a continuous process. And the incremental cost of that is not so high if you were to just buy multiple lines. So this also benefits, and we adapt to the customer requirement. So the challenges today for any person wanting to enter the recycling of PET is collection. So if you have your collection system in place, then, and you have a washing line, I think it becomes a lot more easier. So there are companies like Dalmia here who have a very efficient system. There are other companies also in India. They have adapted, giving bins where they have sensors. When you put it in, it fills up and automatically come and pick it up from different places. So collection of bottles, if you get it organized well, recycling is not a problem. Then the quality of the waste is also, becoming a challenge, because in India we tend to use our wastewater bottles for different uses. They fill oil inside, they fill kerosene inside, they fill sand inside, they fill everything. So, which is very different from other developed countries in the West. So, washing becomes more and more important. And then this process of SSP, we have adapted in such a way that these challenges are also addressed, because we keep evolving on that basis. So this is what we do. Currently, we have a market share of 45% in India. Our lines by 2026, 730 tons per day of recycled polymer will be produced. And we are also participating in the PRS show. So if you all would like to know more, I would welcome you. There are people from Switzerland also available to address any specific queries on technology you have. So thank you so much. I hope I've been able to give you a little bit of an overview, and if you have any detailed questions, I can address it later. Thank you.
Wrong designation. Before we move on to the UTECH panel, I'd now like to ask Mr. Santosh Patil, Sales Director for SI Group, to say a few words.
Namaskar, good morning to all. So, I am Santosh Patil. I am representing a company called SI Group. Basically, we are into the solution providers for various industries like tire, rubber, oil field, adhesives, fuel and lube. And when it comes to plastic industry, we have a big portfolio starting from antioxidants, main antioxidants, inhibitors, UV stabilizers. And recently we have launched a platform called EverCycle, specifically for the recycling, keeping you in the interest of the recycling industry. So everybody must be aware about the India Plastic Pact, which came in 2021, and there are certain targets set by the organizations, and there are directives we are planning to achieve those targets by 2030. And these targets are possible with the support of everyone. So basically what it talks about. So one is use the recycled plastics, or the recycling by 25%, recycled content by 25%, and recycled plastic by 50%. So these are the huge numbers. And to achieve these numbers, the awareness is more important, and there the need of the PRS shows, because there are best practices available across the world. But again, those solution providers needs to come on one platform, sharing those information and learning. It's a good learning experience. I'm also new to this line, and we are learning. So today when it comes to this show is certainly going to help us to understand the market, the customers, or the stakeholders. So that's the point from my side.
Thank you so much. Thank you so much, Mr. Patil. Now we'll move on to our UTECH panel. We have with us three gentlemen who will be talking a little about the PU and foam industry and how sustainability is playing a role, and the importance of the UTECH event in India. So I'd like to ask Mr. Jayant Khatvikar, Managing Director for J Elastomers, to begin.
Good morning, everyone. Thanks for the Media Vision to give this opportunity to express some views about the polyurethane industry, because the Media Vision and other shows arranged by Urethane Technology magazine I have attended elsewhere in the world, and rather we were waiting for this opportunity, this world-class magazine to bring in over here and give a better leverage to all Indian entrepreneurs, as well as who are making some contribution to the new developments and to go it globally. Now, talking about the polyurethane industry, see, industry is divided into multiple products like foams, as it is explained that rigid and flexible. It is known types of foams are available from polyurethane. Then there is a elastomer, then there is a sealant, then there are adhesives, coatings, footwear, artificial leather, binder, and lastly, which is gaining a lot of importance, that talking about the binders, we use the recycle. See, in case of recycled plastic, I'll add some extra point to my earlier speakers. Recycle is based on two items, which is called thermosetting plastic and thermoplastic. Earlier it has been explained about the recycling of thermoplastic. I am going to talk about a thermosetting plastic, which is a more difficult subject, because thermosetting plastic, that it behaves same up to the certain temperature range, and then it disintegrates. There is no chance that it can be revived. So thermosetting plastic is a very challenging material. Now thermosetting plastic, which are thermosetting plastic, is a polyurethane is known. Then you know the epoxies like Araldite and companies. So there is another material which is called thermosetting plastic. Then polyester resins, which are known and made for FRP or GRP, the names people must have known. So these are the few examples for the thermosetting plastic, including some variants of silicons and nylons are also there. So these are likely to pose a big challenge in coming years, to ask the researchers and technologists to break their head and develop some technologies for recycling and come out with some solution. This PRS kind of events will be definitely adding value to it, and moreover technologists from abroad who have must have worked already in their respective countries probably will throw more light and give us India that more footage. Now talking about our industry, I represent Jai Elastomers, which we make them predominantly elastomers, specialized. We are providing the customized solutions. We would like to say that polyurethane variants are ample, having challenges other than foams. Like we do specialized developed clamps for Chandrayaan and Mangalyaan rocket holding clamps for last 25 years. And you know the precision is required because it is not open tender. You have to develop the material which is very suitable and sustainable again. So we have been doing this kind of approach for last so many years for a defense. Another important material we developed, that's model making foam. Which is a commodity, not everybody does it in terms of foams, because the foams which we develop are used as a model for building the frigates and the warships. And in our country, whatever types of warships are being made, they are being tested on the model developed with polyurethane foam for this recycled material. And we have tried so many different variants to improve the quality, keeping the price and other technological aspects absolutely same, intact in indigenously development. Another variant which we are going to do it is called syntactic foam using polyurethane. It's a new technology again. We are the first time we are bringing in India. Like Mangalyaan, Chandrayaan, government is developing the Samudrayaan, which is likely to hit the bottom of the sea as deep as 16,000 feet, something like that. So some specialized foam of syntactic foam for the first time in India we have developed, and the prototype testing is on. So there are many opportunities for the newcomers in India for this kind of challenging material, polyurethane. Otherwise we are only focused and looking at the other countries. So this kind of show is going to give us the new window which will be open, and people should take advantage of this. We are holding the booth at the show. 444 is number to easy to remember. We will invite everybody to join us, and we will explain something better on the spot, and with some actual photographs and actual pieces what we have developed. Also the recycled material, now coming back to the circular economy, for the recycled material we have developed some specialized binders, and not limiting our idea of waste only to the plastics which we generate, that is polyurethane, but we have done the binder testing. About 18 binders we have developed that is based on biopolyols, and these binders bind the heterogeneous material, not only your polymer waste. I am talking about polymer, not only the polyurethane, polymer waste, but the material like rice husk, like coal tar, like the sugarcane bagasse, and all composites can be made and converted into some other tangible product which can be converted either into the form of brakes or in terms of some idea which can be used for a longer time. Even if you make a big boulder and having with density, which will be used as a foundation, so that can be automatically becomes a part of the circular economy, because the plastic is not going to get destroyed for another 1500 years. So instead of fighting against plastic, we should convert friend and make it more like friendly rather than treating as a foe. Okay. So this is my way of doing the things. I would invite some suggestions for us, and we offer this binder technology free of cost to everyone. Whosoever comes forward, I will give this binder technology free. Thank you very much.
Thank you so much, Mr.